Hey, welcome back. So today we're going to find some more values of sine and cosine around our unit circle. If you're ready to work on those and you want to practice, skip ahead to when I start practicing and try them out yourself. But first, I just want to remind us where some of these numbers come from. And the nice thing, all the questions today that we're going to work on, there are only really 9 answers, right? Last time, we only had answers when we were evaluating sine and cosine around the axes. We only had 1, plus and minus 1, and 0. Today we're going to add on a half, again, plus and minus. We're going to add on root 2 over 2, plus and minus, and also root 3 over 2, plus or minus. So it's a little sloppy, but only 9 answers. So you only have 9 to choose from. So every time you have a 1/9 chance of just guessing correct. Let's not guess, but anyways. So where do the rest of these numbers come from? We're going to want to know the values and the coordinates around our unit circle for every multiple of 30. So maybe we'll start with 30 over here. Doesn't really matter. If this is 30 degrees, well, we know a couple things. This is our unit circle, so we can label it. This is 1, right? So this length is 1. And this is going to help us. If this is 30 degrees and this is a right triangle, we have to think back to way back when in geometry class, and this is one of our special right triangles. So as long as we remember our special right triangles, we could come up with this x value and the y value quite quickly. So what were those? Anyone remember? Well, I think the ratio was, for a 30-degree triangle, if the small side was x, then the large side was 2 times x, and the longer of the two sides, sorry, I didn't mean to say large side, the hypotenuse was 2 times x, and the longer of the two sides is x times the square root of 3. So let's apply that. Well, if this is 2 times x, if 1 is 2 times x, well, what's just regular x? You could either know it or you could write out a little equation. 1 is 2 times x. Well, let's divide by 2, and we get a half. Right, so this shorter side is going to be a half. So maybe let's write in that value. Let's fill out the coordinate. This half is the y value, so I have 1/2. Well, what's the longer side? Well, the longer side, if this is 1, right, if x is now, and I should have written this out a little more neatly, if x is a half, well, let's just plug that in, because we just solved earlier that we got a half for x. Well, x is times root 3. So what's root 3 times a half? Well, write it as a nice fraction, keep our 2 in the denominator, and that's where our 3 root 2 comes from. So now this y value here is root 3 over 2. And so that's where that comes from, and I'm going to label this. And one thing we can keep in mind is the short side is always going to be a half, and root 3 over 2, well, what's root 3 over 2? Something like let's call it close to 0.9. 0.8, 0.9, in between there. So the long side, when you're, and I want you to sketch your own little unit circles. Anytime you have a certain long side versus the short side, keep in mind root 3 over 2 is close to 0.8, 0.9. And then you have a half over here for the short side. 60 degrees, well, it's the same triangle, right? Isn't 60 degrees the same triangle? Well, why is that? Well, if this was 30 and this was 90, well, what's the remaining side? Well, we know triangles have 180 degrees. So 30 plus 90, 180 minus 120, well, that's 60 degrees. So we have that same ratio, except the short side now, right, your x value is going to be a half for a 60-degree triangle there. And your longer side now is the root 3 over 2, right? The long side is root 3 over 2. All right, continuing along, our last one, 45-degree triangle. Well, we know that was a special right triangle too, also from geometry class. If this is 45, then this was 45, because that's 90. That is probably the ugliest right triangle I've ever seen. I do have an eraser. Boy, technology. Let's fix that. There we go. Much better, or at least a little better. Right, so if this is 45, then this must be 45, because it adds to 180. All right, we know our hypotenuse is 1. All right, if our hypotenuse is 1, thinking back to this special right triangle, well, what was that ratio? If this was x, well, this used to be x times the square root of 2. So let's make this little equation here. This is x square root of 2, but in our example, we know it's 1. So let's set this equal to each other and solve. And I can divide by square root of 2. And technically, this is the answer, right? 1 over square root of 2, but do we ever leave Radicals in our denominator, no. So how do we get rid of it? Multiply by a fancy form of 1. Right, square root 2 over square root 2 is just 1. I'm not changing anything. So when I multiply, I get root 2 in my numerator. What's root 2 times root 2? Just 2. And so that's where this other number comes from. Root 2 over 2 and root 2 over 2. And that number we can call it, let's call it close to 0.7. Right? Not as long as root 3 over 2, but it's in the middle. It's in between a half. And it then comes root 2 over 2, and the longest side, we said 0.8, 0.9 is root 3 over 2. I forget off the top of my head. So that's where those numbers come from that we're about to use all over the place. And then if you want to take a screenshot, this is something, you don't need to memorize this. What you need to know is those relationships. That's why we just work those out. Like, where do these magical numbers 1/2 and root 3 over 2 and root 2 over 2 come from? Well, it's just our special right triangles from way back when in geometry. Right? So while it's great to have a very firm grasp of the unit circle by 30 degrees, multiples of 30, and I guess also your 45 degrees. I keep leaving that out, but you need to know that. These are the different angles you need to know. But all these numbers, we said there's only 9 answers. It's just from our special right triangles. All right, so take a screenshot, get a tattoo of that. No, I'm just kidding. Let's try some. All right, let's find the cosine of 3 pi. Well, every time, I suggest draw a picture. Well, I have 1 pi, 2 pi, 3 pi. This is one of our easier ones from last time because I'm just on an axis. What's the x value there? Well, the x value is -1. All right, here's a new one for today. Sine of 5 pi over 4. All right, well, I have 1 pi, 2 pi, 1/4, 2/4, 3/4, 4/4, 5/4. I'm down here, right? And now that is one of my 45-degree triangles. And we said those answers before were root 2 over 2. We just now need to remember we're looking at y. So I know both of my sides are root 2 over 2, but which one is it? Well, if I'm in my third quadrant, that's negative. So I have negative root 2 over 2 for the y value at 5 pi over 4. All right, how about the cosine of 7 pi over 6? Well, 7 pi over 6 is just 30 degrees, or pi over 6 more. And the more accurate you draw these, the better picture you can kind of see, okay, what side are we talking about? Well, this is a 30-degree angle in here. So this is my short side. That's the side that's a half. That's a half for the y value. But like I just said, be careful. Are we looking for the y value? No, the y value is the longer side. The x value is the longer side, and that's that root 3 over 2. But again, be careful of your quadrant. What quadrant you're in? You're in negative zone for x values, right? All these values on the left of 0 are negative. So if I want my x value, I need negative root 3 over 2. All right, next, sine of negative pi. It's like we've done this before. Right, I'm right here. I'm on the y-axis. My y value, the x-axis. My y value there is just going to be 0. Cosine, 210. Man, I should have chose better examples, but that's okay. 210, right, just 30 degrees past my 180 there. And again, I'm forming that same triangle before. And these two, you'll notice, they're the same exact question. Right, so it doesn't matter if I'm in degrees or radians. I still have, for my x value, that negative root 3 over 2. And again, I'll just write it larger over here. The distance really isn't negative, but that's my coordinate over here. All right, how about sine of negative pi over 3? All right, pi over 3. Negative pi over 3, right? If I go down there, if I bring this back up to my x-axis to kind of get a picture of my triangle there. Well, all right, I have 60 degrees in here. This is the long side, this is the short side. Which one do I care about? I want the y value, right? If this is the longer side, well then that's the root 3 over 2. But again, be careful. Are we in positive y's or negative y's? I'm below my x-axis. That's a negative y value, right? If I went to write this out, I'd be at positive 1/2, comma, negative root 3 over 2. And this is the one we want because it's my sine value. All right, how about 3 pi over 2? All right, 3 pi, I have 1/2 a pi, a whole pi, 3 pi over 2. I'm at the cosine value. What is the x value there? That's just 0. Easy one. All right, how about the sine of 135? That's a multiple of 45 degrees. So I already kind of know what my answer is. All my answers for my 45-degree triangles are going to be root 2 over 2. But we just have to be careful, is it positive or negative? So if I come over to 135 degrees, right, that's like over here. That's a bad 45 degrees, but that's okay. Let's see, I want the sine, the y value. So that is positive, right? I'm above the x-axis. I have a positive root 2 over 2. All right, continuing along. I have sine of 2 pi over 3. Let's see, where's 2 pi over 3? Well, 2 pi over 3 is approximately over here. Right, if 2 pi over 3 is 120, well, 30 past, right? Sometimes I still think in degrees, even though I try to familiarize myself with radians as much as possible. Let's draw our little picture. I'm just going to draw a little dotted line. Well, now, if I'm sine, it's the y value. That is also the larger side of the triangle, right? So I have root 3 over 2. Continuing along, how about 11 pi over 6? 11 pi over 6, that's going all the way around till I'm pi over 6 left to go to my full rotation, right? So I'm over here. Really horrible drawing, sorry. So I want cosine, that's my x value. So my x value is the longer side. And it's positive, right? Because I'm in my positive in my first quadrant. So I have root 3 over 2. How about 90 degrees? Cosine of 90, bam, right up there. What's that? The x value up there, just 0. How about sine 180? Bam, we did this one already, right? What's the sine at pi or at 180? Well, the y value there, 0. How about cosine of 750? Oh, I don't know cosine of 750, but I know that 360 and another 360 is 720. Again, especially if you play some of those snowboarding games or whatnot, you'll know 720 or 1080 if you go another one. But if I go 30 degrees past, let's see, I go 360. Another 360, 720, and I'm going to go 30 degrees past because I have to get to 750, and I'm really just looking at a 30-degree angle, right? I don't care how large it is. This is some of those coterminal angles from our earlier lessons. And I'm looking for cosine, which is the x value, again, the longer side. So I have root 3 over 2. How about sine of 7 pi over 4? Let's see. Pi over 4, 2 fours, 3, 4, 5, 6, 7. Right over here, right? A 45-degree angle. I'm going to always connect that back to my x-axis there. And I already know my answer is going to be some form of root 2 over 2 in all of these 45-degree triangles, but I have sine. Sine in my 1, 2, 3, fourth quadrant is negative, right? The y value is negative down here. So I have negative root 2 over 2. All right, sine 11 pi, negative 11 pi over 6. Let's be careful of our direction. So I have just pi over 6 left to go till I get back to 2 pi, a full negative 2 pi. Or 30 degrees, right? This is my 30-degree triangle. And again, you'll start to see these repeat, right? There's only so many angles that we know exactly. They're either multiples of 30 or the 45s. And so I'm looking at sine. This is the shorter side. I'm in my first quadrant, so it's positive. Well, the shorter side of a 30, 60, 90 triangle is 1/2. Finally, we got a 1/2. I think we were getting mostly 3/2 for the long sides. And my last question, 4 pi over 3. 4 pi over 3, let's see, I'm at, let's go one more pi over 3, about there, right? Because I go to 3 pi over 3 and 4 pi over 3 is down here. My angle looks like that, or my triangle looks like that. Cosine's the x value, so this is the small side, right? This is the small side, and my small side in my 30, 60, 90 is 1/2. And let's just be careful, let's double check our sign. If I'm in my third quadrant here, what's the x values? Well, the x values are negative, so I have negative 1/2. All right, so those were some quick questions on evaluating sine and cosine with all of the angles, all the special angles around our unit circle. Hope that helped. Thanks for watching, and please subscribe to After School Extra Help. Also, leave a comment if you'd like more examples or if you want another topic to be covered.